Hi students, 12th standard chemistry, unit 5, coordination chemistry. So in this session I am going to teach you the isomerism in coordination compounds. Okay. So last year itself we have studied isomerism in organic compounds in fundamentals of organic chemistry. So this year we are going to learn the isomerism in coordination compounds. What is isomerism? Isomerism, which is nothing but when two or more compounds having the same molecular formula but differ only in their structure as well as physical and chemical properties is said to be isomerism. Okay, what is isomerism? When two or more compounds having the same molecular formula but differ only in their structures as well as physical and chemical properties is called isomerism. Okay, the compounds will exhibit isomerism or called isomers. Okay, isomerism is broadly classified into two types. The one is structural isomerism and the another one is stereoisomerism. What is structural isomerism? The structural isomerism arises when there is a difference in the structures of the coordination compound. When there is a difference in the structures of the coordination compound. Okay, that time we can get the structural isomers. And then what is stereoisomers? Stereoisomers arises when there is a difference in the spatial arrangement of the atoms. When there is a difference in the spatial arrangement of the atoms. Okay, that time the stereoisomerism occurs. Okay, this structural isomerism again classified into four types. The first one is ionization isomerism and the second one is hydration isomerism and the third one is linkage isomerism and the fourth one is coordination isomerism. This stereoisomerism is classified into two types. The one is geometrical isomerism and the second one is optical isomerism. So in this class we will discuss about the structural isomerism briefly with the example. Okay, so we will see the structural isomerism first. What is structural isomers? This type of isomerism arises when there is a difference in the structures of the coordination compounds. So let us discuss the types of the structural isomerism. The first one is linkage isomers. Okay, what is linkage isomers? This isomerism arises when an ambidentate ligand approach the central metal atom. When an ambidentate ligand approach the central metal atom. What is ambidentate ligand? Okay, that you should know to find out what is linkage isomerism. Ambidentate ligand, which is nothing but, here in this example we are having the ligands. I am taking the nitrite group. I can draw the structure like this, N double bond O. Okay, in this way I can draw the nitrate group. Okay, ambidentate ligand, which is nothing but such type of ligand will have the two donor atom. Ambidentate ligand will have the two donor atom. So in this case nitrogen is one donor atom and the oxygen is one donor atom. You see the example, this is the example they have given to explain the linkage isomers. Okay, if I draw the structures for these complex ion, I can get the structure like this. Okay, but in the first compound the nitrogen will be attached with the central metal atom. In the second case the oxygen will be attached with the central metal atom. Okay, so the molecular formula everything is same, only they differ in their structures. The connection of the atom to the central metal atom, only they differ in this position. Okay, so that is called linkage isomerism. Here nitrogen will be acting as a donor atom and here oxygen will be acting as a donor atom. Okay, so linkage isomerism arises when an ambidentate ligand approach or attach to the central metal atom. Is it clear for everyone? Yes. So the next one is coordination isomers. What is that? Coordination isomers. From the name itself we can say, okay, if the coordination compound is having both the cation as well as the anion, there will be a possibility of the exchange of the ligand between the cationic complex as well as the anionic complex. that time we are getting the coordination isomer. Say for example, consider this as a cationic complex and this as a anionic complex. What will happen? There will be a interchange of ligand between these two. Okay, interchange of ligand in the sense within the compound, within the molecule, the ligands will be interchanged. Say for example, here with the cobalt NH3 is attached, with the chromium cyanide ion is attached. Okay, this ammonia will interchange here and this cyanide will come to the copal. Okay, so if I write the structures here, how can I write? CO, in the place of NH3 I will write CN6. Then here in the place of cyanide I will write ammonia. So in this way we can interchange the ligands. Okay, if it is exchanging like this means that is comes under coordination isomers. Okay, so the next one is ionization isomer. What is ionization isomer? What is ionization? First of all, when the compound, if I am taking the coordination compound and I am adding solvent to it, what will happen? The simple ion will ionize first. Okay, so in the ionization isomerism, the counter ion will be exchanged with the ligands. So that is called ionization isomerism. Counter ion, which is nothing but the simple ions. Okay, so in this case, this is the example they have given. This is the coordination complex. Here this chlorine as well as bromine will be acting as a counter ion, which means the simple ion. Okay, it can also acting as a ligand. So this, in the place of chlorine, bromine also can come. In the place of bromine, chlorine also can come. Okay, so in this way we can get the ionization isomer. If I write the example, what I will get? In the place of chlorine I will write bromine, in the place of bromine I will write chlorine. Okay, there is an interchange of ligands and the simple ions. This isomerism is called ionization isomerism. Okay, so in the first case, if I take this complex, I am adding the solvent to it, what will happen? Bromide will be ionized first because bromine is outside. So it will be removed as B or minus, it will be eliminated as its ions. But in the second case, what will come out first? Chlorine will come out first. So this is called ionization isomers. Okay, so then the next one is solvate isomers. Okay, from the name itself we can say easily the exchange of solvent molecules with the ligands. The exchange of solvent molecules with the ligands is called solvate isomers. For example, for solvent molecules, water, ammonia and alcohol. These are all the example for solvent molecules. Here they have given one compound. So if the compound is exchanged with the solvent molecules, I can get 3 possible isomers. Okay, these are all the 3 possible isomers I have written. In the first compound, the compound will exhibit violet color, and here in this case chloride ion will be ionized first. Okay, but in the second case 3 chloride ions there, so here 3 chloride ions will be removed first. But in the second case, the second complex will be existing in pale green color. It will the simple ion will be eliminated. Here is 2Cl. Okay, see here Cl2. So 2 chlorine ions will be eliminated here and are ionized here. Okay, in the third case, this compound or this isomerism exhibits dark green color. Okay, in this case only 1 chlorine will be ionized. Okay, so this is called solvate isomerism. Hope it is useful for everyone. Thank you.